Hello, welcome to today's lesson. Today we're going to focus on the topic 3.1, relative atomic mass and relative molecular mass. At the end of the lesson, pupils are able to conceptualize the meaning of relative atomic mass and relative molecular mass based on the carbon-12 scale. Calculate relative molecular mass and relative formula mass. Have you ever tried counting the number of sugar grains on a teaspoon? Never. Why? The size of the sugar grains are too small, so that we cannot count on it. If you have a look at the sugar grains under the microscope with a power of 40 times greater, then you can see them. Chemists face a similar problem. Atoms are extremely small. It is difficult to determine their number and the mass of each atom. Thus, chemists use the concept of relative atomic mass by comparing the mass of atom of an element to the mass of atom of another element that is chosen as the standard. Let's have a look at the figure 3.1 here. Figure 3.1 shows the mass of carbon atom compared to hydrogen atom. One carbon atom equals to 12 hydrogen atoms. At first, chemists use the hydrogen atoms as the standard because it is the lightest. However, many elements cannot react with hydrogen, and the existence of hydrogen as gas at room temperature makes it difficult to handle. Finally, in year 1961, carbon-12 atom was agreed upon internationally to refer as a standard. Figure 3.2 showing relative atomic mass of helium. One helium atom equals 4 units. What's mean 4 units here? 1 unit equals 1/12 of the mass of one carbon-12 atom. We're going to learn this later. Therefore, we do not need to know the actual mass of an atom. Relative atomic mass, AR. Mass of an atom is very small and it's difficult to determine. However, it can be determined by comparing its mass with mass of a standard atom. In year 1961, the International Unions of Chemists and Physicists agreed to use isotope carbon-12 as standard atom. Why isotope carbon-12? Yeah, there are a few factors. First, it is solid at room temperature, found in most substances. Thus, the relative atomic mass of an element is the average mass of one atom of the element compared to 1/12 of the mass of one atom of carbon-12. This is the formula related. Relative atomic mass equals average mass of one atom of an element compared to 1/12 mass of one atom of carbon-12. Relative atomic mass does not have unit. Example, the relative atomic mass of nitrogen is 14. Therefore, the average mass of one atom of nitrogen is 14 times greater than 1/12 of an atom of carbon-12. Relative molecular mass, MR, and relative formula mass, FR. Mass of a molecule is also calculated by comparing its mass with the carbon-12 atom. It's the average mass of a molecule compared to 1/12 of the mass of one carbon-12 atom. The formula is relative molecular mass, MR, equals average mass of one molecule compared to 1/12 of mass of one atom of carbon-12. For example, the mass of one molecule of oxygen is 32 times heavier than 1/12 of one atom of carbon-12. Thus, the relative molecular mass of oxygen molecule is 32. Relative molecular mass does not have any unit. The term relative molecular mass can only be used for substances that are made of molecules. For ionic compounds, the term relative formula mass, FR, is used instead. Let's have a look at the calculation part. How to determine the relative molecular mass or relative formula mass? Actually, the relative molecular mass or relative formula mass can be determined by adding up relative atomic mass of all atoms present in the molecule. Repeat. Okay, it can be determined by adding up relative atomic mass of all atoms present in the molecule. Example 1. Molecular substances, which we're going to find out the relative molecular mass. Water molecule with the formula H2O. Its relative molecular mass equals to 2 times the relative atomic mass of hydrogen, such as 1, plus relative atomic mass of oxygen, 16. Thus, the relative molecular mass of water is 18. Example 2. Ionic substance, hydrated copper 2 sulfate, CuSO4, 5H2O. Relative formula mass for copper, hydrated copper 2 sulfate is CuSO4, 5H2O. Okay, to get its relative formula mass, you have to adding up all the relative atomic mass of every single atoms present in it. Thus, copper is Ar is 64 plus Ar of sulfur 32 plus 4 atoms of oxygen, and every single one the Ar is 16. So that you're going to use 4 times 16, which you're going to get 64 here. Plus 5 because the relative molecular mass of 5 water molecules are involved. So that's why you have to use 5 multiplied with the relative molecular mass of water, such as 2 times 1 is the relative atomic mass of hydrogen atom plus the relative atomic mass of oxygen. So here you're going to get altogether 5 times 18, such as 90. Thus, the relative formula mass of hydrated copper 2 sulfate is 250. I wish that you can understand. Let's do some practice so that you can master it. That's all for today.